Okay, question 23. You just need to determine the sizes of angles alpha and beta. So we'll write down the critical information first. We do know that PQT is 64. And we know that PTS is going to be 115. Okay, so alpha is going to be pretty simple. It's in the same segment, so that one's going to be 64. Okay, hopefully you can see that it's in the same arc, so we just use the bow tie, top of the bow tie, top of the bow tie the same. Now, we will also be able to know that QTS is going to be 180 minus 115 to get our straight angle in here, because it's obviously a straight line that goes from Q to S. So 180 take 15. 180 take 115, sorry, equals 65. And therefore 65 is the angle that you've got in the middle there, and therefore to get beta it's just going to be 180 minus 64 minus 65, and that's going to get you 51 degrees. Not too much that needs to be done for that one, hence only 2 marks. For the next one, we've got a cyclic quadrilateral, and we've got some things that we need to fill in, so I'll pause and fill those in. Okay, this one's actually not too bad once you recognize the theorem of the alternate angles. So this 25 in here is going to be 25 in there. So remember, it's whenever there's a tangent point, the angle in between the triangle and the tangent on the outside on one side will be the inside on the other. So that one's going to be 25, and then the other one over here is going to be 33. Now that means that you can end up solving for this interior angle of QPS, because it has to add up to 180 in the triangle of QSP minus your 33 and your 25. Them two together make 58, which means you're going to get 122 left over. And if that's 122, what kind of quadrilateral is RQSP? It's going to be a cyclic quadrilateral, which means that opposite angles have to be supplementary, which means it's going to be 180 minus 122 equals 58 degrees. And that's how we solve that one. Just obviously making sure that you're writing that the quadrilateral is cyclic, and obviously writing down your theorem that you used to end up solving for these angles up here. And that's all we do for that question.